Hey guys, in this tutorial we'll see like how we can select an object in a 3D scene and move it around with the mouse pointer. For this I will be using the raycast method, the raycast technique. So I'll be casting a ray from my camera towards the object that I want to select. Okay, and when we talk about casting a ray, we are talking about this static function raycast from the class physics. This function raycast takes as inputs an origin from where we are going to cast our ray and a direction in 3D space, in world space. And the direction is defined between the camera position and the mouse pointer. And here is the problem. The mouse pointer is in screen space coordinate system. And we need to have the vector direction in world space. And for this, I will be using this method called screen point array that it takes as an input a vector 3, which is going to be my mouse position, and it will return a direction and a point origin. Okay, the point origin most probably is going to be the same as the camera position, the exact same one, but the direction is going to be between the camera and the mouse pointer, and it will be like a vector 3 in world space. So we have our solution. It's screen point array. We'll use it to get those two values, the origin and the direction. Okay, and to go back to physics raycast, how it's working, how this static function works exactly. It takes as an input like an origin in world space and also a vector 3 direction in world space and some other stuff, and it takes also as an input an output parameter defined as a raycast hit type. Okay, we will see everything in detail later when we start writing our C# script. And this function return a Boolean value. What does that mean? Like when we emit, like when we cast a ray and our ray intersect with an object or collide with an object, this value, this Boolean value is true. And of course, when this value is true, the output parameter will give us like the identity of the object that my ray collided with, and also the point of intersection between my ray and the collided object. So, and some other data. Okay, so let's start, you know what, let's start by writing the script. So let's create like a script in my script folder, right click, C#. I will call it like mouse drag or just mouse. Okay, I'll start by doing some declaration statements. I need to create some variable. The first one, since I'm using physics raycast, so I need to define a variable type raycast hit. So I'll write private raycast hit ray hit. Okay, semicolon. I'll write like a var equal var ray, it's a variable, equal camera screen point to ray parenthesis input mouse position. So when we write like this ray and we add the dot operator member access, we'll see like that we have our direction already and the origin. So we are fine for now. Let's now take care of the physics raycast. So I'll do like var equal var hit our Boolean variable equal physics dot ray cast, and as origin I'll just write ray dot origin comma, and direction ray dot direction, our output parameter ray hit. So if let's write some decision statement. If hit is true, then I'm gonna create another variable of type game object, private game object collide obj, and here collide obj equal ray hit. I told you before that ray hit, the output parameter of raycast, once this value is true, it will give us the identity of the object. I mean, the identity of the object with its position and all that stuff, and also the point of intersection between my array and this object, the position in word space. So ray hit, and when we add the dot operator member access, we'll see like all these data that we can have once this value is true. If it's false, all these are nothing. So this value need to be true to get all this. Okay, so once our this value is true, we will associate ray hit collider dot game object semicolon to this variable, which is like of type game object. That's why I added this. Okay, let's see if it did work or no. I'm gonna just add now, just as a temporary line code, debug.log. I want to have the name of the collided object in my console screen, just to make sure that it is working. So debug.log collide obj dot name, okay, semicolon. Save. I'm gonna drag my mouse C# script to my camera, so it's here, so it's fine, clear. Let's execute. It's working. No, nothing happened, and I know why. It's working only with a plane, as you can see here. And I know why. Because our object don't have a collider. The plane has a collider, a mesh collider. But my objects don't have colliders. So I'm going to add it now. Component physics box collider. Just make sure that the collider is covering the entire object. Component physics box collider, and even if it's a cylinder, I'm gonna add to it like a box collider, okay, just to make things simpler. Okay, so let's see now. Yes, it's working. Okay, but Now I want to cast a ray only when I click with my mouse button, the right button, not the left one. I mean the left one, not the right one. So let's add this line of code, a decision statement. So if input dot get mouse button 0, I think it's 0 for the left button. So if it's true, because it's a Boolean value, if it's true, I will cast my ray. When we just to explain this, var, it means just this value, this variable are temporary variable. Okay, this one is a Boolean value, a variable, and this one I'm not sure about it yet. It has like the origin from where my array is going to be casted, and the direction in all space, but I don't know the type, the exact type of this one. Local variable ray, it's ray of type ray. Okay, so I'm fine. I just need to close my curly braces here. Okay, so let's see if it's working like that. So nothing happened, but when I click, it's happening. Okay. Okay, so it's working. Let's go back to our script. Okay. So now we need to make, when I click with my mouse and my array intersect with the object that I want to select, I want the object to be locked on my mouse pointer and follow my mouse movement. Okay, because it's locked. So I want to make it lock when my array intersect with the object that I want to select. Okay, so so let's do it. And for that, I'm gonna need to do some other declaration statements. I'm gonna create a variable of type float, and it's going to be my distance. It's the distance between my origin, which I am sure it's the camera position also, and the center of gravity, or the pivot point of the selected object. So it's going to be this distance. Okay, and also I need to create a variable of type vector3. So vector and I'm gonna name it and it's going to define my variable is the position of my selected object. So I'll name it pos obj. Okay, you can name it whatever you want. Okay, so once there is like a hit, what I'm going to do, I'm gonna write this expression, distance equal ray hit distance. Okay, and outside my curly braces, I'm gonna write pos obj for my selected object to be locked on my mouse. Its position needs to be a function of my camera position and the direction of my array and the distance between the camera or the origin and my object. Let's write my script. Let's keep writing our script. So this variable vector3 pos obj equal the new position that is a function of the camera position and the direction of my ray and the distance. So this is the new position of my object. So the object can be stay locked on the mouse pointer. So this was obj equal ray dot origin plus, so this one is a vector 3, plus distance, which is float, multiply the vector direction, ray dot direction, semicolon. Okay, and the collide obj now equal new vector 3 parenthesis cos obj dot x comma cos obj dot y comma, and I don't want its z value to change. I mean, I want so my object, this one, will move only on this plane. Its z value need to never change. It need to keep, okay, because here we are just changing the y and x, but we are not changing the z value, so it doesn't need to change. That's why I'm gonna keep it. So collide obj dot transform dot position dot z, and I saw something wrong here. It's not just collide obj, but I need to add to it like transform position equal all this. So let's see if it's working or not. Let's save this. We have I think I know what's happening. Yes, I forgot to write here the E. Okay, well, yeah, it's working. Whoa. So I know what's happening, because when I select this one and I go inside the big box, suddenly, like, I start my ray will intersect with this big box and it become my selected object, and I don't want this to happen. I want, when I lock on one object and I don't release my finger from my mouse button, I want to be always, even if I go inside another object, I want this object to stay locked on my mouse pointer. So for this, what I'm going to do, I'm going to add another variable, private, Boolean this time. Lock, I'll name it just lock obj, semicolon. And here I'm going to add with this one, so when hit it's true, and lock obj is false, because I want my selection to happen. So hold on. Okay, when I select an object, like let's say I select this object and I click, I want this operation to happen only one time before I release my finger from my mouse button. Okay, so for this, that's why I added this Boolean value. So when it's false, it will do it, and then just after, I'll just put this one, lock obj equal true, and when I change it to true, it won't happen again, unless, I'm gonna add here else. It means that when I release my finger from my mouse button, lock obj equal false. So to select another object, I need to release my finger and then select that object. That's why I wrote this, okay? That's why I added this Boolean value. So in the beginning, it's false. So when I click, we have this, and this one is going to be true, okay? So this happened, like we will associate the array heat collider game object to my variable game object, and then I will calculate the distance between the object and my origin from where I casted my ray, which is the camera, and then I'm gonna change this Boolean value to true, so it doesn't happen again. It will happen only one time. And when I release my finger from my mouse button, it will become like false, so I can select another object. Let's see if it's working as I said or no. So yeah, it's working. It's working. Let's now go inside this big box. Damn, it's still not working. Why? I think I didn't save. Yes, I'm sure. Yes, I didn't save. So it didn't update. So let's do it again. So it's working as before. Let's now. Yeah, it's working now. I'm going to release my finger from my mouse button, and then I'm gonna select this one. Yeah, it's working. And this one, it's working. So it's working. Okay. Just to keep explaining what we did already, I made this drawing. Let's imagine that we are not like in a 3D space, like here in 3D dimension, but in 2D. It is the same. I made it in 2D because it's simpler to visualize. Okay. So let's imagine that this point, this green point, is our camera. So when we click towards this object, another green point, we will have like this vector direction. This vector has a particular thing that its magnitude is 1. We call it like a normalized vector, like this one as well. They are normalized vector. Their magnitude is equal to 1. Okay. So when we multiply a distance float by this normalized vector, we will obtain a vector, the red one, between the camera and the object. Okay, and we already have like the camera position is the vector between the camera and our origin in world space. So when we add those two vectors, this one and this one, the red one, we will obtain like the blue one, which is the position of my object from the origin. So here we see like V, the vector, camera, object, this one, is equal to distance multiplied by the direction, the vector direction, which is, it works only when this vector is normalized. I mean, when its magnitude is equal to 1. And usually like screen point array, the directions that we'll get from screen point array is a vector 3 normalized. Okay? We don't need to worry about it. But I can show you in the future, like in my next tutorial, how to, I mean, it's easy, it's really easy to create your own method to normalize any vector. So let's go back to our drawing. As you can see here, like this vector, the red one, the camera, O, plus the vector object camera, this one, is equal to this big vector, which is the object position from the origin in world space. Try to, it's the same in 3D. I made it in 2D because it's simpler to visualize, okay? It is just missing the Z axis, that's all. Okay. So let's go back to, I hope it's clear. If it's not, just send me an email or contact me in YouTube or whatever. I mean, I'll try to help you if I can.